Now we are going to some properties of this adjoint. So there is a theorem. Let H be a Hilbert space. H be a Hilbert space. Let A and B fall in BLH. A and B are the bounded linear operators on H. Then our first property is A plus B star equals A star plus B star or B star plus A star, whatever may be. This is our first property. A plus B star equals A star plus B star. How to prove this one? This can be proved by this way. Consider for that proof. Consider inner product X A plus B star Y. Consider inner product X A plus B star of Y. A plus B star, A plus B all star is, this is adjoint of A plus B. Okay. So which is equals inner product by our definition of this adjoint, it is inner product A plus B of X Y. But the linearity to the first variable, that is inner product AXY plus inner product BXY. This is inner product AX plus BXY. Again by the linearity, it is inner product AXY plus BXY. That equals, again by using the adjoint of A and B, it is inner product X A star Y plus inner product X B star Y. That equals inner product X A star plus B star Y. Okay. So listen, we start from here. That means finally inner product X A plus B star Y equals inner product X A star plus B star of Y. Then from here we conclude that this A plus B star equals A star plus B star. Okay, this is our first property. If A and B are any two boundary linear operator on H, then A plus B star is nothing but A star plus B star. Okay. Now we are going to the second property. Suppose K is K following K is any scalar. Then K A star equals K bar into A star. This is another important result. K A star equals K A star is not K into A star. K A all star is not K into A star. It is K bar into A star. K bar into A star. Complex conjugates. How to prove this one? Come to the proof. Consider inner product X K A star of Y. So it equals inner product by the definition of adjoint, it is K of X Y equals K into inner product AX Y. Okay, that equals K into inner product X A star Y equals inner product X K bar A star of Y. So finally, X into inner product X K A star Y equals inner product X K bar A star Y. So that means from here it is K star for any scalar K, K star equals K bar into A star. So that is our second result. Okay, second property. Now we are going to our third one. AB all star. AB all star equals B star A star. AB all star equals B star A star. How to prove this one? That's again immediate. AB all star. Consider inner product X AB star of Y equals inner product by definition of adjoint, it is inner product ABX of y equals inner product AB of x, A of B of x, that is composition, y, that equals inner product B of x, A star of y, A star y, Bx A star y, equals inner product x, B star A star y. So finally inner product x, A B star y equals inner product x, B star A star y. That means it is A B star equals B star A star. So this is our third result. Now again prove A star star. That's our next interesting result. A star star equals A. How to prove this? A star star equals A. So you can start from where? Inner product x, A star star of y. By definition of adjoint, it is inner product A star x of y. Okay. Inner product A star x of y. So inner product A star x of y is inner product y A star x conjugate. We know inner product x y equals inner product. That is the property of inner product. Inner product x y equals inner product y x conjugate by x bar. So inner product y A star x bar. Inner product y A star x bar equals, it is inner product A y x bar. Again by the property of, again by the definition of adjoint. Inner product A y x. Inner product A y x bar equals, this is inner product x A y. Inner product A y x bar equals inner product x A y. So finally we have, it is A star star equals E. Okay. Now we are going to another interesting one. That is when A satisfies this, when A is a bounded linear operator on a Hilbert space X, then A has these properties. That is A plus B all star equals A star plus B star, A star star equals A, K all star equals K bar into A star, A B all star equals B star A star. Suppose A is invertible. A is invertible. A is invertible means simply A inverse exists, also it will fall in BLH. So A is invertible if and only if A star is invertible. A star is invertible. A is invertible if and only if A star is invertible. And what is the inverse of A star? So A is invertible, this one. So listen. If A is invertible, if A is invertible, if A is invertible, A is invertible means there exists some C in BLH, C in BLH, such that, why? Because A is in BLH, A is in BLH, C in BLH such that AC equals I equals C, AC equals I equals C. Now, AC equals I equals C, now taking adjoint on both sides. That is AC star equals I star equals CA star. What is I star? Is it I? That's a consider before going to the mainstream, before going to this proof, consider this I star. Do you say that I star equals I? Is it clear? What is I? I is an identity function, that is I of x equals x for all x of all in x, or h at all, not xh, which is a Hilbert space. And what about inner product Ix of y? Inner product Ix of y equals Ix means x, so it is inner product x of y. Okay. Inner product IXY, that is, but inner product IXY equals, inner product IXY equals inner product X I star Y. So finally, from here, inner product IXY equals inner product XY, inner product IXY is inner product X I star Y. So left sides are equal, right side is also equal, that is inner product XY equals inner product X I star Y. This means inner product X Y minus I star of Y equals 0. That means I minus I star of Y. This is I minus I star of Y equals 0. That happens only when I equals I star. Okay, this is inner product X I minus I star of Y equals 0. That means I minus I star is 0. That is I equals I star. Okay. So here we use this result. AC star equals I star equals A star. But what is I star? We prove I star equals I. I star equals. We prove here I star equals. So this becomes inner product AC star. We know AB star is B star A star. So it is C star A star equals I star means I equals A star C star. CA all star. So C star A star equals I equals A star C star. That means this happens means when A star fall in BLH, there exists some C star fall in BLH. This is interpreted as A star fall in BLH. Then if A star fall in BLH, then there exists some C star fall in BLH such that A star C star equals I equals C star A star. That implies A star is A star inverse exists. A star inverse or inverse of A star. Inverse of A star exists. Inverse of A star exists. Moreover, this A star inverse sum is fallen in BLH. So that implies A star is invertible. That implies A star is invertible. Okay. So when A is invertible, A star is invertible. So first part is finished. What about its reverse inclusion? Reversely, suppose A star is invertible, if possible. If A star is invertible. A star is invertible means we know that A star all star is invertible. Why? We know that when A is invertible, here we prove A is invertible, its adjoint is invertible. So by using that argument, when A star is invertible, its adjoint, that is A star star is invertible. A star star is invertible. A star star means A, that is A is invertible. Okay, that is, it is given A star is invertible, but here we know that when A is invertible, its adjoint is invertible. Here A star is invertible, its adjoint, that is A star all star, is also invertible. But we know what is A star all star, it is A, so it is invertible. Okay.